welcome to my channel. So in this video I'm going to discuss the topic shift registers in digital electronics. Now let us see the outline of my presentation. So here the outline is we are going to see about the basic shift register functions. Okay, so and we know that the basic shift register functions in digital electronics are basically it has four types, that is serial in, serial out shift register, that is SISO, and serial in, parallel out shift register, that is SIPO, and third one is parallel in, serial out shift register, that is PISO, and parallel in, parallel out shift register, that is PIPO. So these are the basic four shift registers are available in digital electronics, right? So here the how the data is moved, or the how the data is transferred from one stage to another stage. Based on that, it has been classified into four types, that is data is transferred from one device to another device. So it can be done by using different patterns, data format, that is serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. Okay, and also one more register, that is bidirectional shift register, that is left shifting and right shifting. Okay, now in this video I am going to explain the basic shift register functions and serial in, serial out shift register operation, right? So what is basic shift register functions? Okay, so I already explained in the previous video, that is flip-flop concept in digital electronics. So whatever the storage element in digital, so it is mainly the basic element for storage is what? Flip-flops. Okay, what is flip-flop actually? A flip-flop is a storage device which is used to store one bit of information. Okay, either it can store 0 or 1. Okay, only two binary operations, either it is 0 or 1. Okay, so it can store, each flip-flop can store one bit of information. Here what is register actually? So register is the basic definition for register is what? A group of flip-flops. Okay, for example, a 4-bit register, consists of 4 bit, because 4 flip-flops are there, because each flip-flop is capable of storing one bit of information. Already I told the basic element for memory is what? That is flip-flop, right? So here the register is what? A group of flip-flops, right? So here the register can do the two functionalities. One is what? Data storage and data movement. That is data storage means what? If it is a 1-bit flip-flop, if it is single flip-flop, 1 bit will be storage. If it is a 2 flip-flops, 2-bit storage can be done, right? If it is a 3 flip-flop, 3-bit storage. It depends on number of flip-flops, right? And data movement, this data movement can be done is what? That is data transfer from one block to another block, either it is a serially or parallelly or okay, so that pattern. Okay, so that pattern is what? Data movement operations, right? Okay, these are the two basic functions which are involved in register. Okay, and the storage capacity, already I told you, the storage capacity of register is what? Total number of bits that can retain, is it right? So total number of bits indicates what? If it is a 8-bit register, 8 flip-flops are there. If it is a 16-bit register, 16 flip-flops are there. Okay, so the length of the storage is what? It depends on the number of flip-flops are used. Okay, so that is the concept over here. Then next one, so here the shift register consists of arrangement of flip-flops, that is each stage of shift register represents 1 bit storage. So that is each flip-flop is capable of storing 1 bit of information. Okay, and the shifting capacity permits what? Movement of data from stage to stage, either it is a serial fashion or parallel fashion. Okay, serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. Okay, so it depends on the data movement between the different devices, right? Which works under, that is basic clock pulses, right? And the main difference between register and counter, so that you must know. So here the counter mainly deals with what? A sequence of states. For example, if it is a up counter, a sequence of states from, that is 0 1 2 3 4 5, that is state 0, state 1, state 2, state 3, that is what? That indicates counter. So it has a specified sequence state, right? In case of what? Counter. But in register, it does not contain any specified sequence of states. Okay, so it mainly deals with what? The type of data entry. Okay, that the data in and data out. Okay, so here the register is mainly used for what? Storing and shifting of data, whether the shifting can be done left shifting or right shifting. Okay, this is the basic shift register functions, right? Now let us see the first pattern, first shift register, that is serial in, serial out shift register. In this serial, in the name itself, you see here, so serial in, serial out. Serial in means what? Bit by bit pattern. So you're going to give the input as what? Bit by bit, and you're going to get the output as what? Bit by bit. That is serial out. Okay, here the serial fashion is what? Data can be transferred from one device to another device in terms of what? Serially, that is bit by bit pattern. So that is the concept over here. See here, the diagram clearly shows what? See here, data in is what? Bit by bit. Okay, only a bit by bit transfer, and data out also only a bit by bit pattern. Okay, this is what? Serial in, serial out shift register data pattern. Okay, now let us see. I'm going to explain this serial in, serial out shift register by using 4 bit register. Okay, 4 bit shift register. So already I explained that is what 4 bit shift register means what? You need 4 flip flops are required to design 4 bit shift register. See here a 4 D flip flops are there. D, that is flip flop 0, flip flop 1, flip flop 2, and flip flop 3 is there, right? So 4 flip flops are there. That's why it is called as what? A group of flip flops is called as register, 4 bit shift register. Okay. Now I am going to explain this concept with an examples here. Here the input data. See here, first serial data input is given to flip flop 0 D. The output of first flip flop is given input of second flip flop. The output of second flip flop is given input of third flip flop. The output of third flip flop is given input of third flip flop is given input of fourth flip flop, that is flip flop 3, and finally you are going to get the Q3, that is serial data out. See the red in that is Q0, Q1, Q2, that is what serially you are sending the data, and you are going to get the data as what? Serial data out, and the common clock is given for all flip flops. Okay, this is what actually the data pattern of that is serial in and serial out shift register. Now I am going to explain this with one example. So here the example, I have designed 5 bit shift register. Here the 5 bit shift register is what? The 5 bit shift register means 5 bit. Here 5 bit means 5 flip flops are required, right? So here 5 flip flop 0, flip flop 1, flip flop 2, flip flop 3, and flip flop 4. Okay, totally 5 flip flops are there because here 5 bit register. If you are designing 8 bit shift register means 8 flip flops are required. Okay, the same pattern, but you just see the data pattern here. Here serially they are giving one. See here, the first flip flop output is given input of second flip flop, and second to 3, 3 to 4, 4 to 5. Okay, and finally you are going to get the data output. This is what serial fashion, serial in, serial out, right? And common clock is given for all these flip flops. Okay, now I am going to explain the example. Initially all these flip flops, that is Q0, Q1, Q2, Q3, and Q4, as I am assuming that as 0. Okay, you just see the first clock pulse. See here the first clock pulse. See, this is the first clock pulse. So at this instant, okay, see here the Q0, see here Q0, Q1, Q2, Q3, and Q4, all are what? 0 only. Here the data input is what? 1. So during the first clock pulse, that is rising, I am dealing with here rising edge of clock. Okay, so this is rising edge of clock, and this side is what? Falling edge of clock, right? So that is from 0 to 1, that is rising edge of clock, right? So during that instant, so here the data input is what at this instant? 1. Okay, first data I am feeding to first data. So if you feed the first data during the first rising edge of clock, the Q0 is 1. So here the Q0 is 1. Actually, see here, see the diagram. So Q0 is 1, but remaining all are what? Zeros only. See at that instant, see at that instant, this this instant, okay, this instant, see all are 0. But here only Q0 indicates what? That is 1, logic 1, right? Q0 indicates logic 1. Sorry, here okay, I'm taking pen for this one. Okay, serial in, serial out shift register. So this is the okay, this is the diagram, right? So here see here, this at this point you are having what? First data, the 1 indicates Q0 is 1, and Q1, Q2, Q3, Q4 are all are zeros. During the second clock pulse, see the second clock pulse. So what the function here? And the first output, the first flip flop output is given input of second flip flop. During the second flip flop, what is the output of q1? Q1 is 1. See here, q1 is 1, but the data is also 1. Okay, at this point data is second, during the second clock pulse the data is 1 as well as q1 is 1. Okay, both are 1, remaining all q2, q3, q4 are zeros, right? And go to third clock pulse. See the third clock pulse. Okay, this clock pulse, third clock pulse. Here the third clock pulse indicates what? So the input is what? 0. But if input is 0 means what? Q0 is 0. But what about q1? Q1 is what? That is q1 already the output 1. So that is given clock input of what I mean flip flop 3. So flip flop 3 also 1. That is q2 also 1, right? And but q0 is 0 and q1 is 1 and q2 is 1 during the fourth clock pulse. So here the input at that instant, what is the input? Data input. This data input has always fed it into flip flop 0, right? So here one is there now, so that one will be activated over here, right? And the q1 is what? The previous state, whatever the previous state of q0 is there now, that is 0, that will be retained over here. And q2 is q2 means whatever is the previous state here, 1, so that 1 will be retained over here. And q3 means what? That is q2 status is what? At that instant 1, so that 1 will be retained. And q4 is what? 0 only. Then after next clock pulse, 1 2 3 4 5, fifth clock pulse. During the fifth clock pulse, see here q0 is what? 0, 0. So now actually data input is 0, so q0 is 0. So previously q0 is what? 1, so that will be retained into q1. So previously q1 is what? 0, so that will be retained to q2. So previously for q3, so previously q2 value is what? 1, so that will be retained into q3. So then for q4, previously what is the q3 value? That is 1, so that will be retained into for q4. Okay, that is what? Data is moved from what? Bit by bit fashion from one flip flop to another flip flop. That's why we are sending the data from data what? Serially, and we are taking the data as what? Serial output. Okay, after fifth clock pulse, the first data will be enabled over here in the q4. That is q out will be enabled. Okay, so this is the actual concept of serial in, serial out shift register. This is one of the type of shift register which is available in digital electronics. So the length of the shift register is varies the number of flip flops. For example, if here we are dealing with what? 5 bit shift register. If you use 8 bit shift register, 8 flip flops are required. If you use 16 bit shift register, 16 flip flops are required to design that one, right? So because the basic operation is what? The flip flop is can able to store 1 bit of information, right? Okay, so hope you understood and enjoyed this video. So please like, share and subscribe this video. Thank you.